So when you're at this stage, you are quite advanced already. You either move all the way through chapter 6 in the book, or you have coded your data and built up your coding system, coded all your data, and now you want to actually do something with your coded data. A bit more sophisticated than just double clicking on a code and outputting the quotations. And this is what this video tutorial is all about. So I start again this presentation to introduce you mainly to the query tool because it's the most difficult to understand. And when I explain the query tool, you get an overview of all the operators that are available, and you also need the co-occurrence or the proximity operators for the co-occurrence tool. So once you understand it here in the query tool, then the co-occurrence table will be just a piece of cake. I have to move advanced numbers in my PowerPoint. So if you open the analysis menu, you see we have the word cruncher, we have the query tool, the code matrix, table entry, views, and the code's primary document table. The last option you mainly need for case-based comparison. If you want to compare your females and males, or your 20-year-old with your 40-year-olds, or different locations, so different characteristics of your data, or different document types, different years, and so on. The code matrix you could use for case-based data, but also for other type of data, as will be the case with the Children Happiness project. And both of these tools will provide quantitative answers in the first place, and then you can move on to your data in the second step. And most of the time you then will also use the query tool. So these two tools are working in conjunction with the query tool. So you should master the query tool as well, even though these are easier to implement. The word cruncher is data analysis in a sense, but it comes before you have coded. So if you're at that stage already, you've coded the data, maybe you can just skip forward to a few minutes in the video. The word crunch provides information about absolute and relative frequencies of all words per document. So once you added documents to the data and you want to get a feel of what's in there, especially if you haven't done the interviews, or if it's just data that comes from a survey or data you picked up from the internet, PDF files for your literature review and so on, you just want to get a feeling of what kind of content is in there. Then the word cruncher is a great tool. You can present it in a word cloud or as an Excel table if you want to maybe do something more with the numbers. But Atlas is not for quantitative content analysis. There are other programs who can do that much better, finding words and contents and so on, and they're really geared to then quantifying your data. Atlas is your tool for also doing qualitative analysis on qualitative data, even though it does provide some numbers as well. So this is the word cloud on the Children Happiness project, and so we see children is comes up quite often, happiness and so on. We can exclude all the we and they and the and all these words, so we can prepare a stop list, but you have to prepare this basically for yourself. I've searched on the internet with some prefabricated stop list, but that seems to be something you need to do yourself. You can use the slider here to kind of show these words occur at least 14 times and so on. So this is not showing you how to do this, and just give you an idea that that's there, giving you an impression of what words occur in your document. So I want to spend some time here on the query tool. The query tool retrieves data segments by their attached codes. So that part on retrieves data segments is very important, because the result is always going to be the quotations and your data. You can see how often they occur, but that's not really the focus. It's a quotation, and the query tool can only retrieve quotation, and that does have a consequence on how you need to operate it. We have 3 groups of operators, Boolean, proximity, and semantic operators, and in turn I'm going to explain them to you. And what at first at least sounds strange, that queries are entered in RPN notation, in reversed Polish notation. The reason for that is that it basically follows the quick click logic of the computer, and it doesn't need any syntax. So you don't have to learn any parentheses, when to set them, and dots and commas and whatever. It just you click what you need, and once you get the hang of that, it's actually quite easy. But people are always a bit put off when they hear reverse Polish notation. What's that? It's called Polish notation because it has been invented by a Polish mathematician who also got sick of tired on all these parentheses and syntax you needed to set in order to get what you wanted. You can open the query tool alongside. If you have a big screen or two screens, it's under the analysis menu, and you will see the three group of operators here. And in the software, if you move along with your mouse, a short help text is going to be displayed, helping you to understand what these operators are. You can enter codes and code families into a query, and then we have three fields here on the side, and I will explain them while I actually show you the tool live. Yeah, here we always get the results, quotations, and here the number of results. See, it's quite insignificant here. So the important aspect is that bit. What is the answer? Or, well, the answer you still have to give by reading the quotations, but it actually finds those quotations who hopefully are relevant for formulating your answer. So here we have the three group of operators, yeah, the Boolean operators, or, X, or, and, not, semantic, down, up, sibling, and here the proximity operators, within and closes. So I just watch the red bit here, is overlapped by, overlaps, follows, precedes, and co-occur. And I will explain why we get for within and closes, overlaps, overlap by, obviously we get like the two poles of them. I like to spend a bit on the Boolean operators because they often mixed up. Yeah, so that goes back to set theory, and that you had maybe in 8th, 7th grade, whatever, or even earlier than that. So we have two amounts here. Yeah, this amount A and amount B. And then we have the operators or and that I want to focus on right now. So I don't have a board here right now, but we will see the solution in a bit. But just before I give you a solution, if I now say we want to find everything, what, you know, in these two circles would be A or B, and what would be A and B. Just try to think a moment about it. And I'm now already giving you the reverse Polish order. Yeah, we won't in Atlas enter A or B, or A and B. We would enter A, B, or A, B, and. Yeah, so I'm repeating this again because just to get it into your head, we first click code A, then we click code B, and then we click the operator or. Or we click code A, then code B, and then the operator and. Or if it's a proximity query, we click code A, code B, co-occur, code A, code B, within, code A, code B, and closes. Yeah, so we first click the arguments, which are A and B, or code, whatever other codes we might have, and then the operator. So that's a very quick introduction without having now a chalkboard or a flip chart to show you the point of the reverse Polish way of entering. It's first the arguments and then the operator. So you had some time to think about what would be A, B, or what would be A, B, and. Yeah, and is just the intersection. And or is both of it. All of A plus all of B. So you can think in your mind that or is like plus, and it's not like our everyday and. Yeah, if we have we have guests, or yeah, and then we put all drinks on the table, and then we say, on the table there's water, well, there's some beer, some wine, please serve yourself. Yeah, well, water and beer and wine in Boolean terms would taste horrible, because it would be all in one big jug. Yeah, we would actually, in terms, if you would talk like a mathematician, we would say on the table we have water or beer or wine, please serve yourself. Yeah, so keep that in mind. Or is like a Boolean, or is like plus, and the and is just the intersection. That means in terms of coding, you have one quotation that has two codes attached, and why we back in the software I'm going to show you. Yeah, so in Atlas is quite, or like any software, quite precise. If it's one character less or more, you won't find anything. If it's just if you use the AND operator, so it needs to be exact same quotation that has two codes attached to it. Yeah, so or is all of it, and it's just the intersection, and XOR is either or without the intersection, and not is everything else but. And you need that in combination with other operators. Give me everything where A and C co-occur but exclude B. Yeah, then we need the not operator. Because if we imagine we just have two codes, B has been occurring 20 times, and we have 2,000 quotations, and we do a B not, we get 1,900 and IT quotations. Yeah, so 2000 minus 20, and then that's not very useful. So the not operator always works in conjunction with other operators. That also can show you that the queries can not just be A and B, or it can be A, B, or C, co-occur, D, not, and. That would be how it works. But we get to that later. Yeah, let's start slowly. So much about the Boolean operators. Now I want to talk a bit about the proximity operators. They're basically 5. We have overlaps, is overlapped by, within, and closes, and as it is, proximity means proximity here in the margin area, and also would fit under it if you click co-occur, because with and we have one quotation as mentioned, and we would have two codes attached to it. We have no example here on this slide. The reason why we have overlaps and is overlapped by has to do with the fact that Atlas can only retrieve quotations, as I mentioned in the beginning. It cannot retrieve what is here indicated as line 2. This is not a quotation, so it's not an object for Atlas. So you can either retrieve quotation A, the quotation coded with A, or the quotation coded with B. And if you want to get everything coded with B, you have to start entering code B first. So if you enter then B and then A, and if you want that circumstance here exactly, then you want is overlaps. We want overlaps if you want the B in that situation. If you want the B in that situation, we need to use within. Yeah, as here, as an example given here from a life history interview where somebody talks, a long time about childhood. So we have a long segment with childhood, and then within it we have friendship. And we only want to get the sections where people talk about friendship and not the very long childhood segment. So what do you click then? I'll give you a minute to think. We have the code friendship and we have the code childhood. How you click? In the reversed Polish order. So we click with the code always, you can remember that, whose quotation we want to read. So we want to read about friendship. So let's click on friendship, double click. Then we double click on childhood. And then we need to choose the operator. And then we say, okay, that's a within. So within that other big segment. So in a sense, the reverse Polish order really helps us to think through our query. We think about, okay, which codes we need, whose segment we want to read. So we start with friendship, then childhood, and then we can think about the operator. Yeah, so first click on the code or the code family you're interested in, and then you think about the operator. And if it doesn't really matter whether it's in, encloses, overlaps, overlap by, as it often the case is with normal interviews, unless you have that situation like that, then you just click co-occur. Do these codes co-occur in the margin area in whatever way? So oftentimes you probably will start with the co-occur operator, unless you know specifically how the data is coded and that you need specifically encloses or within. Yeah, so of course there are examples for that as well. But Atlas offers all these varieties of these operators because of the different types of data we might have. If you have video data, you might be very much interested if, for example, action A is going on already, somebody else is entering the room, that might be code B, and whether action A continues while somebody enters the room or it stops, if that would be a video coding. In that sense, yeah, it would stop. Then B would not be within A, but it also not, it's not overlapped by A, so it overlaps, so that you know, okay, action A is going on, somebody enters the room, action A stops. Yeah, and then you can ask very, very specific questions having these very specific operators. But if it's not about those kind of questions, you may just as well work with co-occur. Then we have precedes and follows. That's if you want to specify a distance. That can be a distance in terms of characters, number of characters, number of paragraphs. It can be time, it can be frames in video data, and can be pixels in images. So they actually don't have to overlap here in the margin area. It can be a gap in between, and you can define how big the gap has to be. That's when you need precedes and follows. So now we are to the semantic operators. Well, I explain them because they are there. But the way I usually tell people how to build a coding system, and if you haven't seen that video, there is one on how to build up an efficient coding system, it would now end up with network views like that. Yeah, what these network views represent is a category code with their subcodes. But that means using the network view function for just structuring or sorting your codes, and it's then not sorted in your code list. Yeah, Atlas doesn't have a hierarchy yet. It will come with version 8, and we have to work with these prefixes. But as I do also explain, it's not always bad to have a flat code list and then to sort it with the prefixes, because having a tree is also not always the best option, because people make lots of mistakes in order to when there is a tree, and to sort and structure their codes into a tree, because the same rules apply that also I explain in the video on building an efficient coding system, because with the prefixes essentially a hierarchy you build. So I always would advise you to build your higher and lower order codes in your code manager, in your code list, and not using the network view function. But I need to kind of show you that in order to show you what the operators mean. So up means you take one code, get the quotations and also the quotations of that parent code. Down goes the other way round, everything what is below it, then you would get all the quotation of that code, and sibling all of the quotations from the codes on the same level. So all the orange one, all the blue ones, all the whatever, purple, violet this is, but not the quotation from the parent code if it's sibling. And if you have a one level hierarchy, well, putting this all in a code family, as I usually do anyway, if once a category is developed, we'll do the same trick. So you didn't even operator, you just double click on the code family in the query tool. But this is what these operators do. And I would never say they're not never going to be useful, because there might be really true hierarchies in a conceptual sense. Yeah, because what the network view function actually is supposed to do is linking across category, where you conceptualize your work, where you think how is something related, how is the negative effects of parenting related to a certain perception of having children, or certain reasons for having children, and the experience I've made. Yeah, and so it's linking across, and then showing that in a network view function, and not just representing higher and lower, all the categories. And of course, by that conceptual type of work, you might actually getting like true hierarchies in a conceptual sense, and then you might find these operators useful. But the way it's implemented right now, you get all quotations not sorted by code, so you just get a whole group of quotations, and maybe that's another reason why I'm not using these operators a lot. But they're there, and hopefully you know now what they theoretically are doing. So on one last slide, the supercodes. Supercodes are queries, stored queries, like stored hypotheses, for example. They're not like another layer of hierarchy or something. It could be, well, we do reverse Polish again, A, B, or C, co-occur, D, not N, for example. Could be a big query, and we don't want to click this again once we have sorted through and how it all works, and we get the answer, and we just then click on the supercode button, and then it stores that query. And every time we maybe change something with code A at B, we modify the length of the quotation, or we get rid of it because it doesn't fit anymore. If you click on the supercode, it's calculating the query again, and we get the up-to-date result. So it stores the query's intention. It's not permanent. It grows or decreases with your work on the data. So it's always up to date. Normal code is always linked directly to their quotations, and changes are not done automatically. You have to unlink quotation from a code to get rid of that link. A supercode is not directly linked to quotations. That also means it's not showing up in the margin area, which is actually quite nice. Often it's quite full anyway. And if you open up a project, it's not going to show you the frequencies unless you run it. So if you double click, it will run it, and then it will show you has 26 quotations or whatever. So it is calculated every time you click on it. And then, of course, the frequencies stay there in an open session and only show an asterisk again next time you open Atlas. So this is what supercodes are all about. The same for the super families. Yeah, super code families are and you can combine them with Boolean operators and or not. So they combine, your males and females from London as compared to your males and females from another place. And if you add new documents, a super PD family will be updated all the time. Same with supercode families. Yeah, if you get rid of certain quotations within a code, well, your supercode family will always be showing the up-to-date results. So super stuff in Atlas is always about intentions, and it's variable and it changes with your project. In terms of color, yeah, you see it here on the slide, it's red, and you cannot change it. I mean, temporarily, yes, if you give it a different color, but next time you open a code manager, whatever, it's going to have that red color again. So it's always easy to spot, okay, this is not a normal code, it's supercode. You can turn it into a normal code. It's just one click under miscellaneous. That's called a snapshot code. So you take a snapshot from the one moment in time of that supercode. So all of these things are possible if you work with the software. I stop this video now here and create a new video, so this thing is not getting too long and it's maybe easier to handle, to show you how this is actually put into practice in Atlas in a different video. So this is just a theoretical introduction, and then watch the next video of this query tool or analysis tool series in order to see how this looks like in Atlas. So see you there.